So what I'm going to do here is I'm going to talk about how you could prove some of these claims. I'm going to start giving you a toolbox that you could use to establish where those two constants are. Remember, we talked about C and N0? Your game plan is to prove that those two constants exist. We don't need to show where all of them are, we just need to show that they exist. So your job is just to find them and justify that those are valid selections. But that's one part of it. The other part of it is actually writing it down mathematically in a way that is, one, mathematically correct in its reasoning, but also will convince somebody else that you're correct. And this is going to be the main thing I want to talk about. Like I said, there's a lot of drama building up to this. So let's start off doing some examples here. So the first example we're going to do is I want to try proving the following claim. I want to prove 6n squared is big O of n squared. I want to prove this. Now, if you're familiar with what we talked about earlier, I told you something about that constants in front of functions like this, usually you could drop those. I want to show you an actual example of how and why you can just drop these like this. So this is just a concrete example. You could generalize proofs of this nature as well. So here we go. So I'm going to write out a proof proving this claim. And I'm going to use the definition of big O directly. This is the big part of the exercise. So remember, the game plan is as follows. I'm going to state what the definition of big O is within the context of what I'm trying to prove. Then I'm going to follow from that definition how I'm going to select C or N0, whichever I would prefer doing. And then I'm going to follow from that reasoning to get to the other constant. And hopefully by that process I'm going to justify the selections of these and I'm going to write a conclusion. That's at least one standard way of approaching this. Sometimes you might want to simplify the expressions that you write down based on the definition first. You're going to see an example of this probably later. So what's the first thing I usually like to do? I like to say what I'm going to do. So we find constants. Remember, we have to find the two constants. We find constants C. Remember, I told you C is a positive real number. And N0, which remember is a positive integer. Remember the domains of these two numbers. Could you give me N0 as 0? No, because it's a positive integer. The smallest positive integer is 1. So we find these two constants such that, remember, all I'm doing is I'm just taking the definition, I'm rephrasing it, such that for all n greater or equal to n0, 6n squared is less than or equal to cn squared. Okay. With this type of problem, I would usually recommend trying to make the thing on this side, right here, look like what's over here as much as you can. So if it's 6n squared, and that's n squared, can I make 6n squared look like something that's c times n squared? Well, I'll give you a tip. Look at this. 6n squared, then it's a cn squared. What should I pick as c? What c would I pick? Think about it. Remember, this is an inequality. So it's okay if they're equal to one another, right? So maybe what I should do is I should pick, so I'm going to say pick, c is equal to 6. Then we need to find what? We need to find n0, right? Find n0 such that for all n greater or equal to n0, 6n squared is less than or equal to 6n squared, right? Well, what do? Well, I kind of like, you notice I just spell it out, right? Like, when you read something like this, you want to think about it like somebody doesn't know what's going on in your head. You want to spell out the reasoning, but do it in a concise way. So I pick C, then I say what I'm going to do next. But remember, it's one argument. This is just an argument. So now what am I going to say? Well, look at this. Well, we know 6n squared is equal to 6n squared by identity, right? Like, they're the same thing on both sides. Because you could technically divide both sides by 6n squared. You get 1 is equal to 1, right? Well, now this is how I would phrase this. Well, remember, we need to find that n0 point. That's the goal here, right? Well, for all n greater or equal to 1, both sides of the inequality are equal, right? They're in fact equal. So if they're equal to one another, remember, I need to find that point where they're equal or it exceeds it, right? But in our case, the C I picked, they're just going to line up perfectly at all times, which that's okay. So I'm going to choose n0 is equal to 1, and we're done. Now I need to put this all together, right? I need to gift wrap the proof, right? Therefore, by choosing such constants, by the definition of big O, I'm just going to abbreviate definition with def of big O, definition of big O, 6n squared is big O of n squared. And we're done. Note that this box here is just me indicating the end of the proof. So this looks a little wordy at first. Maybe you feel like you maybe can somehow make this a little shorter. You can. But I like to show all my reasoning like this. So I say what I'm going to do. I tell you what I'm going to select. Remember, because this is an existential statement, I just need to show they exist. If I pick C, my goal is then to justify if I pick an appropriate n0, the inequality is always going to hold. That's the whole trick I'm using here. So notice I never justify picking this C. I don't do something to spill it out. This is where the intuition of my proof comes from. So that's the whole trick. Now, the whole strategy I used here intuitively was to make whatever's here look like what's over there. So that's the strategy I used here first, right? So really, it's nice and easy.